Welcome back. Well, we all know what is going to dominate the news cycle from now until November 3rd and probably afterwards, and that is the 2020 election for the presidency. And if you even casually watch the news, you're going to hear tons of statistics and analyses and things of this sort, and trying to make sense of it all, can just about make your head explode. And so I want to look at, say, one particular state, one that's very important in the presidential election, which is Florida. Florida very often is a key state in deciding who wins the elections. And if you watch the 2016 election, you might remember that after it was determined Trump had won Florida, the experts pretty much conceded that he had won the whole election. So what's going on in Florida right now? Well, there was a poll put out by CNN last week, and it says that Trump and Biden are basically in a dead heat. But that was last week, which in political terms is a lifetime, right? Things can change really quickly in politics. So suppose we wanted to take the poll today, or maybe sometime in the future as we got a little closer to the elections. How would we do that? How do political polls actually work? And you might think it's really easy. You might say, oh, come on, Matt, we already know the answer to that. We've already studied all this. In Module 1, we talked about how to take a survey. In this case, the survey is actually really easy to take. You would simply ask two questions. Are you a registered voter in the state of Florida? And if they said yes, then you would say, if you had a choice between the candidates that are on the ballot, who would you choose? And that's the sort of question that it's very hard for bias to creep in. So you have a good survey planned. You would go ahead, you would take a good sample, which means it's random and large enough. And the randomness actually is not too difficult to achieve. You do what's called random digit dialing. And that's what the major polling companies do. They randomly select numbers from area codes that are in Florida. And your sample size, well, we're going to talk about that, but it's roughly on the order of 1,000, somewhere in that vicinity. And so we have a good random sample. Now, what do? Well, the big picture of statistics says after we collect the data, we do exploratory data analysis and we summarize it. So we would just compute the percentage that we're going to vote for each candidate. And that's it, right? Or is it? We're going to see the answer is no, that isn't it. And this is where the course becomes, I think, a little more difficult. And the key point here is that we want to realize what it is we're trying to do. The key mantra that we're going to keep coming back to again and again in this class is that samples estimate populations. And in this particular case, the way that's happening is I want the population parameter, which here is the percentage of everybody, all registered voters in the state of Florida who would vote for a particular candidate. And we'll just say Biden to make things easy, right? Now, we can't get all the US registered voters. So we've already talked about how we deal with that. We get a sample. And from that sample, we get a sample percentage, and we think that's going to estimate the population parameter. And I want to show you this little picture because this is an important point that we're going to really try to get into. The way that we can think about what's going on statistically is we can think of kind of like a bullseye analogy. The bullseye, the thing we're trying to hit, is the parameter. The individual shots are the estimates from the sample. So each one of those dots on the bullseye represents an entire sample. We took an entire sample and computed the percentage. And if we kind of translate this to a number line, okay, we see that if we took a good sample, it's random, it's large enough, the sample estimates are going to be scattered about the actual parameter value. Now here's the problem. I don't know where the bullseye is. And I only get one shot. I get one sample. If I could get all of these samples, right, I could kind of see where the center is, and I'd know where that parameter value is, but I don't. I get a single sample. So the million-dollar question, if we only have an estimate from a single sample, how can we say anything about the population parameter? If I go out and I collect data today, and I find out that 48.6% of the people say they're going to vote for Biden in my sample, what can I conclude about the population percentage? It's not so obvious I can conclude anything, because I know that if you went out and you took the same number of people but a different random sample, you're probably not going to get 48.6. Okay. The estimators themselves are variables. They change from sample to sample. And that's why when you look at polls, you'll never see exactly the same number. So I get 48.6. Well, maybe the percentage in the population is above that. Maybe it's 50. Maybe it's below that. Maybe it's 47. How do I know? So see, understanding how political polls work is not as easy as it seems. What we're going to find out, the answer to this problem, is the most important concept in all of statistics. It's called the central limit theorem. And what it tells us is it tells us that data forms patterns. And specifically, it tells us that the estimators that we get, these shots around the bullseye, don't form a random pattern. They actually take on a normal distribution. And that is the fact that we're going to leverage to be able to make decisions. How do we know this? It's part of probability theory. It's a mathematical fact that we know is true with 100% certainty. So we're going to talk in this module about what that pattern the estimators form actually looks like. And then we're going to go on in the next two modules and talk about how we would test a hypothesis that say maybe Biden was above 48% based on our sample percentage of 48.6. And then we're going to talk about the thing that you hear every day in the news, which is confidence intervals. So if you go back and you look at that study carefully enough, you'll see that that percentage has a margin of error. It's usually around 2%. And that means that 48% is our sample, 48% is our sample percentage, and that plus or minus 2% is kind of like an error bar. It says we think the true percentage, the population proportion, is within 2% of that 48%, or 46% to 50%. So there's a lot to unpack. Enjoy. And if this is one section that if you have any questions, you definitely want to ask me. All right, thanks for watching.